Hello class, this is a video tutorial on combinations part 1. In this video we'll be looking at the general concept and notation of combinations. So first we need to understand what a combination is. So far the way arrangements have been counted had the following conditions: order matters and objects may repeat. They are allowed to repeat, they may not repeat. Either way, the key characteristics of all the arrangements we've done is that order matters. So the main thing I need you to understand is that permutations are ordered arrangements. So for example, how many ways can 6 people be lined up? That is going to be 6 factorial ways. Because in this case, there's no repetitions. If Adrian stands first, he can't also stand second, hence why there's 1 fewer from the total. 6 factorial. How many ways can a 4-digit pin be arranged? Well, that's going to be 10 to the power of 4, because there are 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and in the first digit we could pick 10 objects, and in the second digit we could pick another 10, and so on. Just to emphasize this further, the 4-digit pin 1, 2, 3, 4 is completely different from this 4-digit pin 3, 1, 2, 4. Even though they have the same numbers, the order in which they appear is important. For example, God forbid, if your password was 1234, your ATM would not accept it if you typed it in as 3124. Okay, so order matters. In the exact same way here, how many ways, whoops, don't want to spoil that just yet. How many ways can the podium finish, first, second, or third, be arranged from 8 total competitors? This was using the permutation, which was 8 times 7 times 6, or 8 total objects and 3 positions, and order matters. 8 pick 3, 8p3. Now for certain scenarios, the order in which the objects are arranged do not matter. A very easy example is lotto numbers. Let's say on your ticket, you buy a ticket and your numbers are 1, 2, 3, 4, 5. Later in the week, the numbers that come out on the screen are 5, 3, 4, 1, 2. In this case, this ticket is a jackpot winner because all the numbers are matching. Even though the order is not exactly the same, it doesn't matter in this situation. In this situation, order does not matter. So how could we count this? Well, the concept can be understood initially as a permutation, but then considering the result as a repeated object. So let's recall the following. Well, with permutations with repeated objects, we take the total, and then we just simply divide out the number of ways that divide the number of ways that it can repeat. So let's do this as an example. A lotto draw selects 5 numbers from a total of 40. Well, if the order matters, this would be 40 total objects, and we're going to pick 5 of them. Now let's say those numbers are 1, well actually this is going to be some really big number. It doesn't matter what it is, this is going to be our answer for now. But let's say the numbers that come out on lotto draw are 1, 2, 3, 4, and 5. How many different ways can we organize these 5 numbers in any order? That's 1. Here's 2. 1, 2, 3, 5, 4. Well, we can do 1, 2, 4, 3, 5, and so on. Well, with 5 objects and 5 positions, how many different ways can we put the first number here? Well, there's 5 different numbers, and then 4 different numbers, and then 3, and then 2, and then 1. So there are 5 factorial ways these 5 numbers can be arranged. So we want to remove those repetitions. So in essence, it's not just 40 pick 5. We have to divide out that 5 factorial. And this is what you need to type in to answer this question. Because remember, of those 5 objects, we're dividing out all the possible repetitions that could happen with those 5 numbers. We treat them as if they were identical numbers. So in essence, this is what's known as a combination. A combination is an unordered arrangement. From a total of n objects, the number of unordered arrangements of length r is, and here's how you pronounce it, n choose 3. It is n factorial divided by n minus r factorial times r factorial. Notice how within this, what I'm circling here, that there is the notation for pick notation. So NPR, that is n factorial over n minus r factorial. But when we divide out the repetitions, this gives us n factorial over n minus r factorial. Dividing by a fraction, we flip it, which gives us this notation here. And there we have it. So this notation is for an unordered pair. We are dividing out the number of repetitions that are possible. Now, if you go online, and actually later on in the unit, we actually have different notation for this. This is the one that we're going to use from now on. And the way you pronounce it is n choose r. N choose r. If you go online, you might see it like this, but the two that we will most definitely be using are these two here. So this is just an introduction. We'll do some more examples later, but the main idea is that a combination is an unordered arrangement. Think lotto. Okay. Permutations are passwords. The order matters for permutations. Order does not matter for combinations. So I hope to see you in the next video. Best of luck.